This is now problem number 3. The bent rod of negligible mass is supported. So we have your bent rod in here. This is supported by a ball and socket at point A and a slide bearing at point B. The rod leans against a smooth surface at point D. So that one is a smooth surface. Find all the forces acting on the rod when the force P is equal to 960 newtons is applied. So how are you going to determine all the forces acting on the bent rod? So first, let us try to express P. You try to express P in Cartesian vector form. So your P in Cartesian vector form is now equal to the magnitude of P multiply this one by a unit vector in the direction of P. And the direction of P is from point C to point E. That is now your CE. So are you going to determine again a unit vector, CE? So this is the vector distance, CE. Let's try to divide this one by the magnitude of this vector distance. So that the vector distance CE is now equal to xi plus yj plus zk. Now, let us try to determine now the coordinates of points C. So, the coordinates of point C, and this is the x-axis, so that is equal to 0.6 meter. And the y is equal, okay, so this is your y, and therefore it is 1.2 meters. And then your z coordinate is equal to, so this is 1, that is 0.4, so we have 1.4. And for point E, x is equal to, the x coordinate of point E is equal to 0. And then the y coordinate is equal to 1.6. And the z coordinate, that is equal to 0. Now, let us try to determine now the components of the distance CE. Distance CE. So we have your x, we now have your y, and then we now have your z component. So, your P is directed from point C to E. Again, you try to recall it is head minus tail. So, head E minus C. So, 0 minus 0.6, that is minus 0.6. So, 1.6 minus 1.2. And that one is equal to 0.4. And the Z0 minus 1.4, that is negative 1.4. Hence, your RCE, the vector distance CE, is 0.6, a negative 0.6i plus 0.4y minus j minus 1.4 k. Now, the magnitude of this distance or vector distance is now equal to the square root of 0.6 square plus 0.4 square plus 1.4 square. And this is equal to the square root of 2.48. So that is equal to the square root of 2.48. So in Cartesian vector form, your P is now equal to the magnitude of P, and that is equal to 960. Multiply this one by a unit vector CE. So we have minus 0.6i plus 0.4j minus 1.4k all over the square root of 2.48. So that your vector P is now equal to 960 by 0.6 over the square root of 2.8. So this is equal to minus 365.76 I plus 960 by 0.4 all over the square root of 2.48. That is 243.84 J. And then minus 960 by 1.4 over the square root of 2.48. That is 853.44. That is 853.44 K. Now, therefore, the component of P in the x direction is, so your Px is equal to negative 365.76 Newton. So we get a negative value, hence your Px is now equal to 365.76 newtons. Okay, so this is the x-axis, so it will be pointing backward. So we have your y-axis, your Py is equal to 243.84 newtons. So that is positive, therefore it goes to the right. And your Pz is equal to negative 853.44 newtons, or Pz is equal to 853.44 newtons. So that is negative, therefore your Pz is going downward. If you try to look at your P in here, so it is pointing backward, down to the right. Let's try to draw now the free body diagram of the bent bar. So, support at A is ball and socket support. So we now have AX, that the component of the reaction at A. So we have your AX, and then we have your AY. This is now your AY, and we now have your AZ. This is your A in the Z direction. So this is the x-axis again, this is the y-axis, and this one is the z-axis. So this is the origin of the x, y, z axis. Now, support at B is a single journal bearing. So we have, so at this point, that is now in the x direction. So we have your BX. So this is now your bx, and we have your by. This is now your by. Now, this bar or rod CD is resting on a smooth surface, hence it is normal to the smooth surface and that of the rod CD. So this is now your B, which is in the direction of X. So I'm going to consider this one equal to dx. This is now your dx. Now, your P, let us try to resolve your P equal to 960 into the X, Y, and Z components. So we have the X component is 365.76, and that is backward. Okay, so it's parallel to the x-axis. So this is now your px. Or I'm just going to place it in there. So this one in here is now your px. Y is to the right. So we now have your py. And then your z is downward. This is now your pz. Okay, so we now have the free body diagram of the bent rod. So let us try to determine now dx, bx, by, ax, ay, and az. Okay, so let us try to let's try to get now summation of moment. Summation of moment. Okay, in the ZA direction is now equal to 0, counterclockwise moment positive. So this is now your Z, that is your point A. So this is the ZA axis. This is now your ZA axis. So what are the forces, okay, that will have moment about this axis? AX, AY, AZ, BX, and BY has no moment because they intersect the ZA axis. Now, similarly, your PY has no moment because it intersects the ZA axis. PZ also has no moment because that is parallel to the Z axis. So only PX and DX has moment about the Z axis. So at this point, PX, okay, so your PX in here, that is going counterclockwise. Multiply this one by the moment arm, which is equal to 1.2 minus dx, and the moment arm is still equal to 1.2, and that one is equal to 0. Now the value of px is equal to 365.76 by 1.2 is equal to dx, multiply this by 1.2. 2. Hence, your dx is now equal to 365.76 newtons. Next, let us try to take summation of moment about the x-axis is equal to 0. Again, counterclockwise moment, positive. So this is the x-axis. Again, this has no moment, ax, ay, and az, because it passes or it intersects the x-axis. Bx has no moment, it is parallel to the x-axis. So px has no moment, and dx, that is parallel to the z-axis. Parallel to the x-axis. So the only forces that will going to have moment about the z-axis, we have now your by. By is going clockwise about the x-axis. So minus by, the moment arm is equal to 1. Now, next is your py. So your py, the moment of py about the x-axis is going clockwise if you try to prolong the x-axis in here. So that is minus py. And the moment arm is now equal to 1.4. So that is your py about the x-axis. The moment arm is 1.4. Another is your pz. So minus pz. And the moment arm of pz, this is your pz about the, so that is going clockwise about the x-axis, counterclockwise about the x-axis. And the moment arm is 1.2. So it is 1.2. And that one is equal to 0. So by, transpose that to the other side of the equation, is now equal to negative py. And the value of py is 243.84. 243.84. Multiply this one by 1.4. Minus pz, and pz is 853.44. 853.44 by 1.2. So that your by is now equal to negative 1365. 1365.504 newtons. Hence, your by is equal to 1365.504 newtons. So, the direction of by is supposed to be going to the left. Now, let us try to take moment about summation of moment about the axis ya is equal to 0, counterclockwise moment, positive. So this is now, okay, that is your point A. So let's try to draw a parallel line to the y-axis. And this is now your axis YA. So summation of moment about YA is equal to 0, counterclockwise moment, positive. So we have your BX is going counterclockwise about YA. So that is now BX. The moment arm is 1. AX, AY, and AZ has no moment about YA because all of these three forces intersect the YA axis. Okay, by has no moment because it is parallel to the ya axis. So next is your dx. Okay, so we have dx is, your dx in here is counterclockwise about the y-axis. So that is plus dx, and the moment arm of dx is 1.4. And then another one is now your px. So we have your px is going clockwise about ya. So we have minus px, and the moment arm is equal to 1.4. And this is equal to 0. So that your bx in here plus dx, which is 365.76 by 1.4, minus px, and the value of px is 365.76 by 1.4 is equal to 0. Hence, the value of bx is equal to 0. So your bx is now equal to 0. Next, let us try to take summation of forces in the direction of x is equal to 0 forward. Forces to be positive. So we have ax plus bx, okay, plus dx minus px is equal to 0. So that ax plus 0 plus 365 dx 0.76 minus px. So minus px, and again your px in here is equal to 365.76. 0.76 is equal to 0. Hence, the value of ax is also equal to 0. Next, summation of forces in the direction of the y-axis is equal to 0. So that is, to the right, forces positive. So we have ay. And then we have by plus by. And then we have plus py. So that is now plus py is equal to 0. So your ay plus the value of by is 1365, negative 1365.504, because I did not change the direction of the of the assumed direction of by, which is supposed to be going to the left. So that is plus, so we have to use the negative value or negative sign, that is minus 1365.504 plus py, and the value of py is equal to, so the value of py is equal to 200. So that is 243.84. 243.84. And that one is equal to 0. So that the value of ay, transpose this to the other side of the equation, so that is 1365.504 minus 243.84. Ay is 1121 0.664 newtons. Next, summation of forces in the direction of the z-axis is equal to 0, upward forces positive. So we have AZ. So your AZ and then minus PZ is equal to 0. So your AZ in here is equal to PZ, and the value of PZ is 853.44 newton. So those are the forces acting on the bent rod. This is problem 4. So we have a bar is supported by a ball and socket joint. So this is your ball and socket joint, and 2 cables are shown. So we have this cable at point C and the cable attached at point B. Determine the reaction of the ball and socket joint and the tensions in the 2 cables. So the tension in the 2 cables. Now, I will going to consider now that the tension at point C is T sub 2. So this is therefore the tension. And I'm going to consider this one as T sub 2. And we have the tension in this cable. So I'm going to consider this tension in here as T sub 1. Now, let us try to express T1 and T2 in Cartesian vector form. So, in Cartesian vector form. So, express T1 and T2 in Cartesian vector form. So, for T1, so in Cartesian vector form, T1 is now equal to the magnitude of T1, multiply this one by a unit vector in the direction B. Now, I'm going to consider this one in nearest point B. So, in the direction BD. Again, the unit vector BD is now equal to a vector distance BD all over the magnitude of this vector distance BD. So, coordinates of points BD, of points so we now have your point B. So the coordinates of point B, this is the x-axis, that is the y-axis, and this is the z-axis. So it is equal to 0.550 mm, or that is 0.55 meter. Okay, the coordinates are in meter. And then we now have the y-axis is, the y-coordinate is 0, and the z-coordinate is 0. So we have your point D. So for point D, the coordinates of point D in the x-axis, so that is equal to 0. And the y-axis, that is 600 mm, or that is 0.6 meter. And in the z-axis, so this is equal to 400 mm, or that is 0.4 meters. So let us try to determine now the components of the distance BD. So the components of the distance BD, so we have your x, we now have your y, and we now have your z. So that is b minus b. So this is equal to 0. 0 minus 0.55. So that is negative 0.55. And then we have 0.6 minus 0. So that is 0.6. And then 0.4 minus 0. So we have 0.4. Hence, your RBD is now equal to, you have plus ZK. So that this is now equal to minus 55I plus 6J, 0.6J plus 0.4K. So that the magnitude of this vector distance is now equal to the square root of 0.55 square plus 0.6 square plus 0.4 square. And this is equal to the square root of 0.8225. 0.8225. So that your T1 in Cartesian vector form is now the magnitude of T1. Multiply this one by a unit vector VD, and this is RBD. So we have minus 0.55I plus 0.6J plus 0.4K over the square root of 0.8225. So that your T1 is now 0.55 over this one is now equal to 0.606. So negative 0.606 T1 plus 0.6 over the square root of 0.8225, 0.662, 0.662, that is T1. And then 0.4 over the square root is plus 0.441 T sub 1. Okay, so that is the 4. So we now have your T1x. T1x is equal to negative 0.606. We have your I, we now have your J and K. 0.606 T1, or this is equal to 0.606 T sub 1, and this is going backward. Your T1y is equal to 0.606 662 t sub 1. So that is going to the right. And your T1Z is 0.441 t sub 1, and that is going upward. Next, for T2 in Cartesian vector form, so your T2 is now equal to the magnitude of T2. Multiply this one by a unit vector, C. Are you going to consider this point in here as point E? So that is now CE. Again, your unit vector CE is now again a vector CE all over the magnitude of this vector. So let us try to determine now the coordinates of points. So let's start with point C. The coordinates of point C is in the x-axis. The coordinate of point C is now equal to, so this is your point C, 550 plus 400 is 950 plus 450 is 1,400 millimeter, or that is equal to 1.4 meters. This one. Next is your y coordinate. Your y coordinate is 0 and the z coordinate is 0. For point E, we have x is 0. Then we now have y, so this is now your y. So your y is 350 mm, or that is equal to 0.35 meter. And then your z is equal to 600 mm, or that is 0.6 meter. Now, we now have the components of the distance CE. So we have your x, we have your y, and we now have your z. So again, E minus C. So we have 0 minus 1.4. That is negative 1.4. 0.35 minus 0. So that is 0.35. So 0.6 minus 0. So we have 0.6. So that your RCE is now equal to xi plus yj plus zk. So this is negative 1.4i plus 0.35j plus 0.6k. So that the magnitude of this vector distance is now equal to the square root 1.4 square 0.35 square plus 0.6 square. So this is equal to the square root of 2.4425. 4425. So your T2 in Cartesian vector form is now the magnitude of T2 the unit vector CE is minus 1.4i plus 0.35j plus 0.6k. So all over the square root of 2.4425. So that your T2 is now equal 1.4 over the square root of 2.445 is negative 0.896 T2 plus 0.35 over 2.4425 is equal to, okay, so we now have the free body diagram. This is the free body diagram of this bar in here. So we have the 1,600 Newton force applied 450 mm from point C. And then we have the components of the reaction of the ball and socket. So we have your AX, so it's AX, AY, and AZ. So this is now your cable T2, tension in the cable T2. So let us try to resolve the component of the tension of the cable T2 at point E. So that is now at point E. So your T1, T2X is going backward. T2Y is to the left, parallel to the y-axis, and T2Z is going upward. So your T1, let's try to resolve the tension in this cable, and that is now your T1. So T1X is going backward, T1Y is to the right, and T1Z is going upward. So we now have all the forces acting on the free body diagram of the bar. Now, let us try to take summation. Let's try to take summation of moment about the y-axis is equal to 0, clockwise moment positive. So this is the y-axis. So AX, AY, and AZ has no moment because these components of the reaction at A intersect the y-axis. So we have now your 1,600 is going counterclockwise. So we have 1,600. The moment arm is 400 plus 550. So that is 950 millimeter. So we have now your T1Y has no moment. Okay, so your T1Z intersect the y-axis, and therefore it has no moment. So it is only your T1X. So your T1X is now going clockwise about the y-axis. So minus T1X. Now the moment arm is 400 millimeter. Let's proceed to T2. T2Y parallel to the y-axis, no moment. T2Z intersect the y-axis. So we have your T2X is going clockwise about the y-axis. So minus T2X. T2X, multiply this one by the moment arm, which is equal to 600. And this one is now equal to 0. So we now have this is equal to 152. Okay. Minus 400 T1X minus 600 T2X is equal to 0. So if you try to multiply both sides of the equation by 1 all over 200. 1 over 200. So this will become 7,600 minus 2t1x minus 3t2x. And this one is equal to 0. Let's consider it one as the first equation. Next, let us try to take moment about the z-axis. Summation of moment about the z-axis is equal to 0, counterclockwise moment, positive. So, this is your z-axis. So, ito yung z-axis natin. So, 1,600 Newton has no moment about the z-axis because it is parallel to the z-axis. So let's start with all AX, AY, and AZ intersect the z-axis. Hence, they have no moment. T1Z is parallel, and therefore, it has no moment. Therefore, it has no moment. So, we now have your T1Y intersect the z-axis. Hence, it has no moment. So, your T1X is going counterclockwise about the z-axis. So, T1x. Now, the moment arm of T1x is equal to 600. This one is the moment arm. Okay, so that is 600. Not this one. This 600 in here. Okay, again, 2ty intersect the z-axis. 2tz is parallel to the z-axis. So it is your 2tx. So that is going, your 2tx is going clockwise. Okay, so nandun siya. Okay, so that is going clockwise about the z-axis. So it is minus t2x, the moment arms, it goes clockwise. Now, and this is therefore equal to, so that one is now, multiply this one by the moment arm, and the moment arm is this distance in here. So that is 350 millimeter. So, okay, so dito, that is the y-axis. So dito, okay, so it goes that way. Then, this is now equal to 0. So that your T2x is equal to, or if you try to multiply both sides of the equation by, try to multiply both sides of the equation by 1 all over 50. So 600 over 50 is 12. That is 12 T1x minus 7 2tx. 2 T2x is equal to 0. So your T2x is equal to 12 T1x all over 7. That is 12 T1x all over 7. So let us try to substitute this value in the first equation. So if you try to substitute that one in the first equation, then we now 7600 minus 2t1x minus 3. T2x is 12 T1x all over 7. And that one is now equal to 0. So we have 7600 is now equal to 7.1429 T1x. 3 times 12 over 7 plus 2 is 7.1429. So your T1x is now equal to 7600 over 7.1429. So that is equal to 1064 newtons. That is equal to 1064 newtons. Hence, your T1x is equal to 0.606 T1. So your T1 is equal to 1064 all over 0.606. And this is equal to, so your T1 is equal to 1755.776. 55.776 Newton. So we have your T1y is 0.662 T1. So 0.662 T sub 1, and the value of T sub 1 is 1755.776, and this is therefore equal to your T1y is therefore equal to 1162.324. 0.324 newtons. And your T1z is equal to 0.441 T sub 1. That is 1755.776, or that one is equal to 774.297 newtons. Now, let us try to substitute T1x in this equation. So, from the equation, your T2x is equal to 12 T1x all over 7. Hence, your T2x is now equal to, that is 12, multiply this one by T1x is 1064 64 newtons all over 7. So your T2x is equal to, so the value of T2x is equal to 1824 newtons. Again, so we now have your T2x is equal to 0.896 T sub 2. So we have 18. So I'm just going to have now your T2 is now equal to T2x, and that is equal to 1824 all over 0.896. So your T2 is now equal to 2035. That is 2035.714. That is in newtons. Okay. So we have T2x. Your T2y, therefore, is now equal to 0.224. Multiply this one by T2. So that is 2035.714. Or this is equal to. So we have your T2y, therefore, is equal to 456. Is 456 newtons. And your T2z is equal to, so this is T2z, 0.384 T sub 2, which is 2035.714, and that is equal to 781. So we have 781.784 newtons. Okay, so those are now the components. Next, summation of forces along the x is equal, or in the direction of x is equal to 0. Pointing forward is positive. So we now have AX. So that is AX. And then we now have minus T1x minus T2x is equal to 0. So your AX is now equal to T1x, which is equal to 1064, plus T2x is 1824. So your AX in here is now equal to, we have 2888 newtons. 2888 newtons. So that is the component in the direction of x of the ball and socket at point A. And then next, is summation of forces in the y direction is equal to 0, to the right forces positive. So we have A, y, and then we have plus T1y minus 2Ty minus T2y is now equal to 0. So your AY, transpose this to the other side of the equation. So this will become negative. And T1y is minus 1162.324. 324 plus T2y, transpose that, where T2y is 456, that is 456. Therefore, your AY is equal to negative 706. 06.324. Therefore, AY is equal to 706.324. It goes to the left. Next, summation of forces in the z-axis, in the direction of the z, is equal to 0. We have upward forces positive. We have AZ. So that is now your AZ plus T1Z plus T2Z minus 1,600 Newton is now equal to 0. Okay. So your AZ plus your T1Z is 774.297 plus T2Z 781.784 minus 1600 is now equal to 0. So your AZ is equal to 43.919, and this is now going with a positive value. It goes upward. So this is, it goes forward. This, your AX is positive and it goes forward. Let's try to determine now the total reaction at point A. So the total reaction at point A is now equal to the square root of AX square plus AY square plus AZ square. So that your RA is now equal to the square root of 2888 square plus 706.324 square plus 43.919 square. Your RA is equal to 2973.444 newtons. So this is pointing forward. So up. So that is up to the left. Okay, so that is now the total reaction of the ball and socket at joint or at point A. The bent bar shown is supported with 3 brackets that exert only force reaction on the bar. So we have 3 brackets in here, and they will going to exert only force reaction on the bar. Determine the reactions at supports A, this is your point A, point B, and point C. Okay, so we now have the free body diagram of the bent bar. So we have, this is the x-axis, we have the y, and that is now the z-axis. So we have your 1,000 pound, 100 pound in the direction of the z-axis. We have 50 pounds in the direction of the x-axis, and we have 75 pounds in the direction of the y-axis. This is 75 pounds. Now, we now have the reaction at point A. So, the reaction at point A is in the direction of the y and in the direction of the z. No reaction in the direction of the z of the x-axis. So, this is now your point A. So, this is now your AY. And then we now have your AZ, now we have at support B, so it is in the direction of the Y and in the direction of the X. So we have your BX and your BY. And at support C, we have again in the direction of X and in the direction of Z. So we have in the direction of Z, so this is now your CZ, and in the direction of X, so this is now your CX. Okay, so we now have the forces acting on the free body diagram of the bent bar. Now, if you try to take summation of forces in the direction of X is equal to 0. So we have pointing forward positive. So we have BX plus CX plus 50 is equal to 0. Okay, so this is now the first equation. BX plus CX plus 50 is equal to 0. Or, you try to get now your BX in here is equal to negative 50 minus CX. Or CX is equal to minus 50 minus BX. Now, summation of forces in the direction of Y is equal to 0, to the right forces positive. So we have AY plus by, ay plus by plus 75 is equal to 0. So this is now the second equation. Or ay is equal to minus 75 minus by, or by is equal to minus 75 minus ay. Now, summation of forces in the direction of z is equal to 0, upward forces positive. So we have your AZ plus CZ minus 100 is equal to 0. So that is your equation 3. Or your AZ is equal to 100 minus CZ, or CZ is equal to 100 minus AZ. Now, let us try to get now moment about the x-axis. So, summation of moment about the x-axis. So, this is your x-axis. So, let us try to consider counterclockwise moment positive. Okay, so this one, AZ-AY has no moment, 75 has no moment. So we have BX-BY. So your BX has no moment about the x-axis. And your CX has no moment about the z-axis. So we have your ZZ about the z-axis is going counterclockwise. ZZ, the moment arm in here is equal to 9. So that is 9. And then minus, okay, your BY is now going clockwise about the x-axis. So we have by, multiply this one by the moment arm, and the moment arm is equal to 6. This is 6 inches. That is equal to 6. And this is now equal to 0. So it intersects this parallel, this parallel, this one is parallel, so it intersects the x-axis. Okay, so let us try to consider this one as, okay, so if you try, let us try to reduce this one. So if you try to multiply this one by 1 all over 3, okay, so 1 all over 3, then 3 CZ minus 2 BY is equal to 0. Let us consider this one as the fourth equation. Or your ZZ is equal to 2 BY all over 3. Ni ano daytan? And your BY is equal to 3 CZ all over 2. Okay? Next, summation of moment about the y-axis is equal to 0, counterclockwise moment positive. All forces parallel to the y-axis has no moment. And all forces intersecting the y-axis also has no moment. So, the forces that we're going to have moment about the y-axis is now this is now your bx. So bx is going counterclockwise. So bx, and the moment arm is 6 inches. So another one is cx. So your cx is going counterclockwise. So that is plus cx. Multiply this one by 8 plus 6. That is equal to 14. Minus your az is going clockwise about the y-axis. So minus az, multiply this one by 8 inches. Okay, so we have your 50 has moment about the y-axis. So this is plus 50 because it is going counterclockwise. And the moment arm is equal to 14. Okay, so this is now equal to 0. So that is therefore equal to 0. So, if you try to multiply both sides of the equation by 1/2, so we have 3bx plus 7cx minus 4az plus 350 by 14 over 2 is 350. 350 is equal to 0. Let's consider this one as equation 5. So that is now your equation 5. Now, so from this, your az is equal to, so your az is equal to 3bx plus 7cx plus 350 all over 4. So we now have your az is equal to 0.75 bx plus 1.75 cx plus 350 over 4 is 87.5. So that is equal to 87.5. Next, let us try to take now we now have summation of moment about the z-axis is equal to 0. Then we have counterclockwise moment positive. All forces parallel to the z-axis has no moment, and all forces intersecting the z-axis also has no moment. So this is your z-axis. So your ay about the z is going counterclockwise. So we now have ay, the moment arm is 8. And then we now have your, so this is the z, this first intersect. So we have cx in here. So cz So we now have your CX. CJ is parallel. So your CX is going clockwise. Minus CX. And the moment arm is equal to 9 inches. And this one is equal to 0. I'm going to consider this one as equation number 6. So from equation number 6, your AY is equal to 9CX all over 8, or your CX is equal to 8 AY all over 9. So this time, let us now solve the 6th equation simultaneously. Let's try to solve the 6th equation simultaneously. Now, if you go to equation 5, from equation 5. So your AZ is equal to 0.75 BX plus 1.75 CX plus 87.5. So that is equation 5. Okay. So from equation 1, your BX is equal to, so your BX is equal to negative 50 minus CX. So we now have your AZ in here. Let's try to substitute this value. 0.75 BX is minus 50 minus CX plus 1.75 plus 1.75 CX plus 87.5. 0.75 by 50, so negative plus 87.5. So your AZ is now equal to minus 30. Okay, so this is negative 39.5 minus 0.75 CX plus 1.75 CX plus 87.5. Or your AZ is therefore equal to, so your AZ is equal to, so we have 1.75 minus, so that is 1 CX. Is equal to CX. Okay, so that is CX plus, that is CX plus 87.5 minus 39.5. So 87.5 minus 39.5, that is, no, 37.5. It's 37.5. 0.75 by 50 is 37.5 plus 50. Okay, so AZ is equal to CX plus 50. Okay, so again, from equation 3, if you try to go back to equation 3, your AZ is equal to 100 minus CZ. So that's 100 minus CZ. Let's try to substitute this value in this equation. So we have 100 minus CZ is equal to CX plus 50. So we now have your CX, transpose this to the other side of the equation, plus CZ is equal to, plus CJ is equal to 100 minus 50. So that one is equal to 50. So CX plus CJ is equal to 50. Okay, so from equation 4, number 4, CJ is equal to 2/3 BY. 2/3 of BY. And from equation 6, so from equation 6, CX. So your CX is equal to 8AY over 9. So that is 8AY all over 9. So let us try to substitute ZJ and CX in this equation. So we now have 8AY all over 9 plus 2/3 of BY is equal to 50. 2/3 of BY is equal to 50. Now, from equation 2, your BY is equal to minus 75 minus AY. Substitute BY in this equation. So we now have 8AY all over 9 plus 2/3, and the value BY is minus 75 minus AY is equal to 50. So that is equal to 50. So 8 over 9 AY. So we have 8 over 9 AY. 2/3 times 75 is minus 50. And then minus 2/3 AY is now equal to 50. So that one is now equal to 50. Now, so that 8 over 9 AY minus 2/3 of AY. 8 over 9 AY minus 2/3 of AY is 2 all over 9 AY. So transpose this to the other side of the equation. It will become positive. And that is equal to 100. Hence, your AY is equal to 100 by 9 all over 2. So AY is equal to, so the value of AY is equal to 450 pounds. So that is therefore the value of AY. Now, so from equation 2, BY is equal, your BY is equal to minus 75 minus AY. So your BY is equal to minus 75 minus AY is 450. And this is therefore equal to negative 525 pounds. So negative 525 pounds. Now, so from equation 4, your CJ is equal to 2/3 of BY. So that is 2/3 of BY. So your CJ is equal to 2/3 of by, and that is negative 5 to 5. So your Cj is therefore equal to negative 350 pounds. Now, let's go back to equation 3. Your Az is equal to what? Okay? So your Az, so I'm going to get this equation in here. Az is equal to 100 minus Cz. So your Az is equal to 100 minus and minus 350. So that is equal to 450 pounds. Equal to 150 pounds. And then, from equation 6, your Cx is equal to 8 all over 9. That is 8 all over 9. Multiply this one by. Equation 6 is 8 over 9. Your Cx is 8 over 9 Ay. So that is 8 over 9 Ay. So your Cx is equal to 8 all over 9. Ay is 450. And therefore, Cx is equal to 400 pounds. And from equation 1, Bx is equal to negative 50 minus Cx. So that is minus 50 minus Cx is 400. So your Bx is equal to negative 450 pounds. So it's negative 450 pounds.